The next problem is that during the 2009 regular season, Justin Verlander of the Detroit Tigers and Tim Lincecum of the San Francisco Giants were the top major league pitchers, and the two pitchers had a total of 530 strikeouts. Verlander had 8 more strikeouts than Lincecum. How many strikeouts did each pitcher have? Okay, so I have that these two pitchers, we'll go with V and L. So V and L together had 530 strikeouts. I know that Verlander had 8 more strikeouts than Lincecum. So we could say Verlander plus 8 equals L. So because Verlander had 8 more strikeouts than Lincecum. Now I have L defined by V. So I can substitute that in. So I've got V plus 8 equals 530. I've got 2V plus 8 is 530 because I combined my like terms. I subtract 8 from both sides. I get that 2V equals 522, or V equals 261. Now that I know how many strikeouts Verlander had, I can go ahead and solve for the number of strikeouts that Lincecum had by substituting in 261 to our equation for the number of strikeouts Lincecum had. And I'm probably pronouncing that name wrong. I'm very sorry. So I have 261 plus 8 equals L. So 269 was the number of strikeouts Lincecum had, and 261 was the number Verlander had. Our next problem uses an equation we've seen before, right? That is that interest equals principal times rate times time. So Thomas Flanagan has $40,000 to invest. I don't know where he got this money from, but that seems like a lot of money. And he wants to put part of that money in an account paying 4% interest and the remainder into stocks paying 6% interest. So the total annual income from these investments should be $2,040. So how much should he invest at each rate? So let's go ahead and make a table. I'm going to make a table to keep track of all that's going on. So I've got principal, rate, and I want to put that as a decimal, not as a percentage. Remember, we can convert between them, and the interest. Because what I'm looking at is making sure that the interest, the time is just 1 year, so we can kind of ignore that. I want to make sure this interest adds up to 2,040. So let's let X be the amount of money invested at 4%. So that's X. The rate on X is 0.04. So the interest rate on that will be if I multiply these two together, because I don't know how much principal I'm putting in just yet. So it's going to be 0.04 times X. Now, if I invested X at 4%, how much do I have left at 6%? Well, that's going to be 40,000 minus X. This is the amount of money at 6%. So I have 40,000 minus X. And if I add these together, I get back up to my 40,000. Next, that rate is 0.06. So I have 0.06 times 40,000 minus X. And I need this to add up to, $2,040, right? That's what I'm hoping to make every my annual income off of this investment. That's what Thomas is hoping to make anyways. I don't have 40K. So I know that this has to equal this. So let's go ahead and solve that problem. And that's going to tell us X, which was the amount invested at 4%. So if I have 0.04x, so that's the interest on the amount invested at 4%, plus 0.06 times 40,000 minus x, right? This is the amount invested at 6%. That's going to give me, hopefully, $2,040. That's what I'd like to make off this investment. I need to simplify this. So I've got 0.04x plus 0.06 times 40,000 gives you 2,400 minus 0.06x equals 2,040. I'm going to go ahead and combine like terms here. That gives me negative 0.02x. I'm going to subtract 2,400 from both sides. That gives me a negative 360. If I go ahead and divide both sides by negative 0.02, I get that x equals 18,000. So this is the amount invested at 4%. So the amount invested at 4% is 18,000. In order to figure out the investment rate at 6%, we have to take 40,000 minus x. Well, x in this case is 18. That means I have 22,000 invested at 6%. For this problem, we're going to use a table as well. This is a good one. I know I've got some chemists and some biologists and some biochemists in my class. So this is a really good problem for you guys. So a chemist must mix 8 liters of a 40% acid solution with some 70% solution in order to get a 50% solution, right? That's what we want. So how much of the 70% solution should be used? Let's go ahead and make a table. Let's go ahead and let x be the amount of 70% solution needed, right? That's what we're trying to find. How much of the 70% solution should be used? So I have my liters, which is a capital L, of solution. I have my percent makeup of this solution, but I'm going to put that as a decimal. We typically like converting percents to decimals. And then I have my liters of pure acid, right? Because it's diluted. So if I have an 8-liter solution at 4%, and I take my liters of solution times my percent, that gives me my liters of pure acid. So I have 8 liters. I know I have 8 liters at 40%. That'd be 0.4. If I multiply this together, that means I have 3.2 liters of pure acid. Now we're going to let x be how much of the 70% solution I'm going to use. So its percent is 0.7. If I multiply these together, I have 0.7x. Now my total liters of solution is going to be 8.x, and I need that total to have a makeup of 50%. So if I take 0.5 times 8 plus x, this is going to have to equal this. My liters of pure acid from my 40% solution and my 70 solution needs to add up to the same amount of pure acid in my 50% solution. So these set equal to this is going to be our equation. So I'm going to write that up here, and let's switch to blue. So I've got 3.2 plus 0.7x equals 0.5 times 8 plus x. And I'm going to go ahead and solve this. So the first thing I need to do is distribute on the right-hand side. 0.5 times 8 is 4 plus 0.5x. I'm going to go ahead and subtract 3.2 from both sides. That gives me 0.7x equals 0.8 plus 0.5x. I'm going to subtract 0.5x from both sides. That gives me 0.2x equals 0.8. If I divide 0.8 by 0.2, I will find that x equals 4. So I'm going to have to use 4 liters of the 70% solution in order to make a 50% solution.